Hello, my name is Michael Mantooth. This is my presentation for Doane University General Chemistry 1 or CHEM125, and this is my interactive advanced concept presentation number 2, also called lava lamp. Excuse me. Basically, today we are going to be making a DIY lava lamp, safe lava lamp, using a 20-ounce bottle with some water in it, vegetable oil, food coloring, and an Alka-Seltzer tab. So I've already got my water in my bottle here. So the next thing I'm gonna do is I'm gonna add some vegetable oil. And as I add this vegetable oil, the water and the vegetable oil will not mix because the water is more dense than the vegetable oil. So they mixed a little bit to start off with, but as the mixture settles, the vegetable oil will rise and sit on top of the water. Again, because the vegetable oil is less dense than the water. So the water will stay at the bottom and the vegetable oil will rise and sit on top of it. The next thing I'm gonna do is add some food coloring to the mixture. I'm gonna use some red. Okay, and I'm gonna do the most. I'm gonna add 10 to 12 drops of food coloring. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And just like the water, the food coloring is actually more dense than the vegetable oil, so it, like the water, will kind of go and sit with the water at the bottom because it's, again, more dense. And then the last thing to do to make this a lava lamp is I'm going to add some Alka-Seltzer. And basically the science behind this project is that the Alka-Seltzer tablet is made up of nitric acid and sodium bicarbonate. And in the solid form, as these are solid, they don't react, but whenever added to the water, the nitric acid gives up one of its hydrogen atoms to the base of sodium bicarbonate. Once in contact with the water, again, the nitric acid gives the hydrogen to the sodium bicarbonate and produces a reaction that produces carbon dioxide. So let me get 2 of them ready. I'm gonna add the Alka-Seltzer. And then you'll start to see whenever the Alka-Seltzer hits the water, that chemical reaction starts, and the bubbles are rising because of that reaction. So the carbon dioxide is produced and it needs to rise up through the liquid to be released, and it brings some of that water with it through the vegetable oil. It comes to the top and that carbon dioxide gets released, and then the water and food coloring floats back down because it is, again, now more dense than the vegetable oil because the carbon dioxide was released. So it floats back down to sit back at the bottom, and this reaction continues to occur until there is no more Alka-Seltzer at the bottom, which makes the Alka-Seltzer tablet in this chemical reaction the limiting factor. So the reaction will continue to occur until that Alka-Seltzer tablet runs out and the chemical reaction will stop. We could restart the chemical reaction by adding another Alka-Seltzer tab, and the same thing would start to occur again. It would rise because of the carbon dioxide gas to be released. The water and food coloring would float back down to the bottom until the Alka-Seltzer tab runs out again. And because there's plenty of water down there, the limiting factor is the Alka-Seltzer tab. So that was my experiment. Thank you for watching.